Good afternoon, my dear students. So today in these sessions we are going to learn regarding the types of element library. Types of element, or we can say as element library. Okay. Serial number, this is the element name. According to examination point of view, this is most important. Element name, schematic representation, and remarks. The first one is one dimension bar element. So this one dimension bar element, what we can say here, again we can say as one dimension line element, or what we can say line element, one dimension line element. So let us see over here, this is first node and this is second node. This is the first node and this is the second node. The joining the first node to the second node, first node to the second node, the forming of element is E1. It is represented by E1. But the displacement is here at the node 1, only one direction is there, so we can represent as U1. At the node 2, the displacement I am representing the U2. So this element is having how many node here? 2 node. And how many degree of freedom? 1 and 2. 2 node, 2 degree of freedom. The element gets visible. Okay, the element has 2 nodes and 2 degree of freedom. Clear here? And second one, serial number second. Again we are discussing about 2 dimension bar element. It is represented by 2D bar element. Is it right? So let us see, this is the first point and this is the second point. If joining the first node to the second node, how is it the structure? It is a structure is 2D, 2 dimension. Is it right? If it is 2 dimensions will be there, means x direction and y direction. Is it right? So at the node 1, but how many nodes are there? Here we can say as first node and we can say as second node, the same as it is here only, but I am representing by the line, This is the first node and this is the second node. And then so this one, what we can say here, this representation we can say as link 1. What we can say here, link 1. They having 2 node and 4 degree of freedom. How? Let us see. This is the x direction. If it is rectangle lamina, this is x direction and this is y direction. Is it right? Then we can represent here U1, displacement U1 in the x direction, displacement V1 in the y direction. What about then at the node 2, displacement U2 in the x direction and displacement in the vertical direction, it is represented by V2. Here how many nodes? 2 node and 4 degree of freedom. Each node, how many nodes are there? 2 nodes. On first node 2 degree of freedom, on second node 2 degree of freedom. Total node is 2, degree of freedom is 4. We understood that here how many node? 2 node. First thing is the element has how many node? 2 node. First node, second node, 2 nodes with how many degree of freedom? 1, 2, 3, 4. U1 V1, U2 V2. 4 degree of freedom. Any confusion here? I think so. No one is having the doubt regarding up to here. Third point, again we are discussing about 3-dimensional element. So 3Ds represent the x, y and z, is it right? So next one is 3D bar element. It's the same. I am taking here rectangular lamina like this, but in the exam there is no need to draw this figure, is it right? Just you need to draw this figure only. For the understanding purpose I am drawing this figure. Okay, let us see. This is the x direction, y direction and here z direction. I am using the line element, then you can easily understand here. I am taking here, this is the first node and second node. On each node how many displacement and how many degree of freedom is acting? 3, because we are discussing about 3 only, 3-dimension element. Like first one is u1, the displacement is acting in the x direction is u1, displacement in the y direction is represent as v1, the displacement in the z direction is represented by w1. At node 1 3 degree of freedom is acting. At node 2 again 3 degree of freedom is acting. Total degree of freedom is 6 degree of freedom is acting on this element, 3D bar element. Here the displacement u2 is acting at node 2. u2 is acting in the x direction, displacement in the x direction, and displacement in the y direction is represented as v2, because we are discussing about 2, and displacement in the z direction it is represented by w2. Here we understood that on each node 3 degree of freedom is acting. On node 1 3 degree of freedom is acting u1 v1 w1. u1 is acting in the x direction. u1 we can say as the displacement is acting in the x direction. The displacement is acting in the y direction is v1. The displacement is acting in the z direction, it is represented by w1. And what about at the node 2? Displacement is acting where? At the point of 2, u2. Displacement u2 is acting in the x direction. Displacement in the y direction is acting as v2. Displacement in the z direction it is represented by w2. Is it right? This is for 2D, means x direction, y direction. What about this one? X direction, y direction and z direction. Okay, then we can represent here this element has how many nodes? 2 nodes. Is it right? This element has how many nodes here? 2 nodes with how many degree of freedom here? Total 6. u1 v1 w1, u2 v2 w2. 6 degree of freedom over. Then next one, is linear triangular element. It is visible, I hope so. It's visible, maybe. 4. Okay, serial number 4. First one next one is linear triangular element. Okay dear, we are talking about linear triangular element. So let us, triangular element is having how many nodes here? Total 3 nodes. Let us see, this is my triangular element. Okay, this is first node, second node and third node. How many node here? Total 3 node. First, second, third. On we are talking about linear triangular element. On each node, how many degree of freedom is acting total here? Total 6 degree of freedom is acting. How? Let us see. Because how is it? The structure is linear, in which we are taking here u1 v1. u1 nothing but the displacement is acting in the x direction. Displacement in the y direction, it is represented by v1. At the node 2, displacement is acting as u2. Displacement is acting in the vertical direction is represented by v2. Displacement in the x direction is represented by u3. Displacement in the y direction is represented as v3. So we know very well this element, how many degree of freedom is they having here? 1 2 3 3 na. This element has how many nodes? 1 2 3 nodes with how many degree of freedom here? u1 v1, u2 v2, u3 v4. Total 6 degree of freedom is acting. 6 degree of freedom. Okay dear, serial number 5. Okay, then next one is we are talking about quadratic triangular element. Okay, so let us see. I am talking about which one? Quadratic triangular element. So consider the same linear triangular element. This is first node, second node and third node. So in between 3 to 1, one more load they can easily act here. From 1 to 2, one more load is acting at the median point. From 2 to 3, one more load is easily can act at this point. So this point, what we can say, 4 point, 5 point, 6 point. So in this case, total how many nodes are acting here? They having these 6 node. 1 2 3 4 5 6 node is acting. The 6 node is acting means how many degree of freedom will be acting? It should be double. 12 degree of freedom is acting, because we are talking about triangular element, not the linear quadrilateral element. Is it right? I am talking about quadratic triangular element, in which how many nodes are there? Total 6 nodes are there. How many degree of freedom will be there? 12 degree of freedom. How? Let us see. This is u1 v1. This is u4 v4, u2 v2, and this one is u5 v5, and this one is u3 v3, and this one is u6 and v6. So we understood that here how many nodes are there? Total 6 nodes are there. 1 2 3 4 5 6, and the displacement u1 is acting in the x direction, and displacement v1 is acting in a y direction. At the point At the node 4, displacement u4 is acting in a x direction, displacement v4 is acting in a y direction. At the node 2, displacement u2 is acting in a x direction and displacement v2 is acting in a y direction. Is it right? As well as the same similar concept would be there. So we understood that here total how many nodes are there? Total 6 nodes. How many degree of freedom? 12 degree of freedoms. The element has 6 node with 12 degree of freedom. Okay dear, next one. Okay, linear, next one is linear quadrilateral element. Okay dear, so here I am considering about which one? Quadrilateral. First node, second node, third node, fourth node. We are joining the point first node to second node to the third node, third to the fourth node, and fourth node to the first node. Is it right? So we can present here the first node, second node, third node, fourth node here. So this plane, what we can say here? So this plane we can say as plane 2. What we can say here? Plane 2. And this node we can say as plane 42. What we can say here? We can say as plane 42. At node 1, the displacement u1 is acting in the x direction and displacement v1 is acting in a vertical dimension. Okay, and displacement u2 is acting in a x direction and displacement v2 is acting in a vertical direction. Displacement u3 is acting in a x direction and displacement v3 is acting in a vertical direction, and the displacement u4 is acting in a x direction and displacement v4 is acting in a x direction. So we understood that they having the how many nodes? Total 4 nodes. 1 2 3 4 node, and total how many degree of freedom here? Total 8 degree of freedom. u1 v1, u2 v2, u3 v4, sorry, u3 v3, u4 v4. Total how many nodes are there? 4 node and 8 degree of freedom. This element, the element has how many nodes dear? 4 nodes with how many degree of freedom? 8 degree of freedom. Okay dear. And next one is 7th one. Okay. Cauditric quadrilateral element. Okay, so let us see over here. We are talking about quadrilateral element. First node, same I am taking as a linear quadratic element. I am taking here first node, second node, third and fourth. Is it right? This is the first node, second node, third node and fourth node. But we are talking about quadratic quadrilateral element, in which what I am doing here, I am taking here this one is the node 1 and 2, in between one more point is lies, so it is represented as 5 node, and the node 2 and 3 it is like the median point is u6. We can say this is a 6th node and this is 7th node and this is 8 node, and in center is we can say as 9 node. So in this we understood that the quadratic quadrilateral element in which they having total how many nodes here? Total 9 node, and total how many degree of freedoms will be there? 9 opposite should be 12, 18 degree of freedoms. Is it right? Let us see over here. The displacement u1 is acting in a x direction, and the displacement v1 is acting in a vertical direction. Then at the displacement u5 is acting at the node 5 in the x direction, and displacement v5 is acting at a node 5 in a vertical direction, or we can say as in a y direction. The displacement u2 is acting in a x direction, displacement v2 is acting in a y direction, and here the displacement u6 is act in a x direction, and displacement v6 is acting in a y direction, and displacement u3 is acting in a x direction, displacement v3 is acting in a x direction, displacement u7 is acting in a x direction, displacement v7 is acting in a vertical direction, displacement u4 is acting in a x direction, displacement v4 is acting in a vertical direction. The displacement u8 is acting in a x direction, displacement v8 is acting in a vertical direction. Here in this case, displacement u9 is acting in a x direction, and displacement v9 is acting in a vertical direction. So we can easily represent here this element has how many nodes here? 9 nodes with 18 degree of freedom. Is it right here? How many degree of freedom here? 18 degree of freedom. Next one is 4 noded tetrahedral element. Okay. Same serial number, element name, schematic representation, and remark. Okay. Here 8-1. So 4 noded tetrahedral element, 4 noded tetrahedral element. So let us see over here. This is the first node, second node, third node, and this is the fourth node. We have to join here first node, second node, third node, fourth node. So we can represent here, this is the first node, second node, third node, fourth node. Then here if you want to observe the 4 noded tetrahedral element in which they are acting in a 3 dimension. So this figure, what we can say, this is the solid object. The solid this object is having the x direction, y direction, and z direction. So that's what we can represent. This schematic representation of diagram is solid 285. What we can say here? Solid 285 we can say. So this is how it solid will be there. Any body, if it is solid, that can represent the x direction, y direction, as well as z direction. So this tetrahedral element also solid component. Okay, so that's what I am representing here. This is u1, displacement u1 is acting in a x direction, displacement v1 is acting at a point at a node 1 in a vertical direction, displacement w1 is acting at the node 1 in the z direction. Is it right? Come to this node 2. The displacement u2 is acting in a x direction, displacement v2 is acting in a y direction, and displacement w2 is acting in a z direction. Come to this point, displacement u3 is acting in a x direction, displacement v3 is acting in a vertical direction, and displacement w3 is acting in a z direction. Come to this point, displacement u4 is acting in a x direction, displacement v4 is acting in a vertical direction, and displacement w4 is acting in a z direction. So we understood that here how many nodes are there? 1 2 3 4 node. And how many degree of freedoms are there? Total 12 degree of freedom. On each node 3 degree of freedom is acting, u1 v1 w1. At each node how many degree of freedom is acting? Total 3 degree of freedom is acting. Total how much will be there? 12 degree of freedom. Okay dear? Then we can represent here this element. Okay, this element has how many nodes here? 1 2 3 4 nodes. And how many degree of freedoms? Total 12 degree of freedom. Is it right? Like u1 v1 w1, u2 v2 w2, u3 v3 w3, u4 v4 w4. So we can say as total 12 degree of freedom. I hope so no one is having the doubt regarding up to here. Another one we can say as 10 noded tetrahedral element. Okay, 10 noded tetrahedral quadratic. Okay dear, so let us see this figure. This is first node, and this is second node, and this is third node, and this is fourth node. First, second, third, fourth. Clear here? Then let us see, we need to join this point here from the first node to the third node. Okay, so this is a first node and second node. Okay, and second node, this is the third node. Total how many nodes we got it here? 1 2 3 4. We are talking about how much? Total 10 noded. Okay, then here 1 to 2, one more node is nice, one more node is lies. So this point, what we can say here, this node we can say as node 5, and this is 1 2 4, one more node is there, this is node 6, or this one is what we can say here, node 7. We can say this point in between 1 to 3, or this one what we can say 8 node, and this one what we can say 9 node. Okay dear, in between joining the from 2 to 4, one more node is nice, this one what we can say node 10. So we understood that this is how is it, this is the solid object. This any solid object that can represent x direction, y direction as well as z direction, they can easily represent. So for that reason we can represent here this 10 noded tetrahedral quadratic element we can say as solid 187. What we can say here, solid 187 we can say. Okay, here, so how to represent this figure, let's see. This is u1 v1 w1 and this is u2 v2 w2 and this is u3 v3 w3. Okay, this one is u4 v4 w4. Okay, and this is 5, this is u5 v5 and u w6 and this one is u9 v9 w9 and this is u7 v7 w7 and this is, so it is not looking good only. Okay, u6 v6 w6 and this one is u10 v10 w10. Okay, then we can say as this is the 10 node with 30 degree of freedom. Is it right? Then we understood that it is a solid object that can represent the x direction, y direction, z direction. In x direction it is represented by u1, y direction represented as v1, z direction represented as w1. I hope so you understood very well. Okay, next one is beam element. Beam element. This is the first node and this is the second node. So if we joining the first node to the second node, the forming of element, what we can say here, we can say as element E1. Is it right? So here this is the Q1 and this is the Q2 and this is the what we can say Q3 and this one Q4. So in this case of beam element, each node has 2 degree of freedom. Is it right? Each node has 2 degree of freedom along one Cartesian coordinate, one polar coordinate, another one is rotational axis. One is polar coordinate, another one is rotational axis. So that's what we can that's why we can say as beam element. Okay, so I am representing here. In case of beam element, each node of element has how many degree of freedom here? 2 degree of freedom. Has 2 degree of freedom. Along one is Cartesian coordinate, another one is polar coordinate. This polar coordinate, what we can say here? Rotational axis. Is it right? Along one Cartesian coordinate, one polar coordinate. This polar coordinate, what we can say here? We can say as rotational axis. What we can say here? Rotational axis. I hope so no one is having the doubt up to here. Okay, next one. Okay, serial number 11. Another one we can say as truss element. This is the first node and this is the second node. First node, second node. So the truss element has 2 degrees of freedom along Cartesian coordinate. So like this one, what we can say here, q1, q2, q3 and q4. The truss element has 2 degrees of freedom, 2 degrees of freedom along Cartesian coordinate. Clear? Another one is Xc Symmetric Element. Xc Symmetry Element. Okay, so here in the one dimension Xc Symmetry Element, this Xc Symmetry Element is used to analyze rotation body, or component which are symmetrical about its own axis. Is it right? Let us see. This is my, according to examination point of view, this is the most important. Okay, sometime it is scanning for the 2 marks. One dimension Xc Symmetric Element. Okay, we again let us see this figure. Okay, so this point we need to join this here. This is the axis of the Xc Symmetric Element. So here this is the first node and this is the second, and this one we can say as third element. We have to join this in this way. Okay, let us see. So this one, what we can present here, this can present as q1, q2, and this one is q3, q4, and this point is q5 and q6. So this Xc Symmetric Element are used to analyze rotating body about its own axis. Is it right? This Xc Symmetric Element are used to analyze rotating body about own axis. Okay dear, I hope so no one is having the doubt regarding this session. If you have a small doubt also, you can write in the comment box, and please don't forget to subscribe my channel. Thank you dear.